proposes the alignment of reality and image. It's just really interesting in terms of how science itself, big science, is using visualization to look at its own emerging ontologies. I'll leave it there to give us a sense of that space, a subspace, biomedical. So scientists that I have worked with, in fact, often argue that it is absolutely necessary to keep the metaphor close to the look, whether observed or photographic, of the data's source. Yet the aesthetics of scientific realism may create limits to imagination, tying visualization too tightly to analytic reasoning, which could fail to deploy the transformative power of visual experience. A further challenge to realism occurs when the source cannot be seen, only measured and imagined. Debates regarding scientific realism have included some recognition that the observer, whether an instrument or a human, has an impact on the means of expressing the data for an experiment. And these are long debates. Karen Barad, a physicist and a philosopher of science, observes in Meeting the Universe Halfway that there is not a one-to-one relationship between the ontology of the world and its discovery, as is claimed by the traditional realist. I'll just go back to that ontology. Or perhaps a better one. The common sense view of nature is continually entangled in the theoretical and experimental practices that mark its description, as is human society. Yet science still makes meaning of the sometimes invisible material world, and we need to pay attention to empirical research as it produces ontological knowledge. These observations are equally true when considering large-scale information systems, such as the internet, that are hybrid forms of physics, engineering, human and machine interaction, or agency. The field of data visualization is compelling because it carries the traces of the empirical world and its instruments of measurement and representation. We need to think of data visualizations as technologies. Data visualizations carry with them the aesthetics and assumptions of their contributing technologies. Data visualization technologies absorb the aesthetics of 2D and 3D graphics and animation systems with their formal styles and malleability. In the past decade, a new set of graphic tools, some viable for online visualizations, others only available through high-performance computer networks or in the laboratory, are available as either open source, such as processing, or proprietary software. The more finished the tool, the more the styles and capacities are embedded. We know this from other visual practices. Artists, designers, and computer scientists continue to build and adapt tools to their specific needs. Mashup techniques transcode data from more than one source within single integrated tools, and search engines allowing the usability and ability to mix what were once discrete structural approaches to data types are current. Each new source of data adds structure, aesthetic properties, and limits. Mitchell Whitelaw, who has some great work in this exhibition, by the way, dubs these practices data bending as they layer context and can allow for the emergences of new imagery and meanings. Not surprisingly, the most illustrative scientific visualizations draw from or map onto photographic imagery. So we'll start with this one. And I find it interesting how, as we slide away from the photographic, there's more and more space for experimentation within science itself. So this image is a 3D model of a virus structure in which 6 different proteins are interacting in complex ways. The data was captured using electron microscopy. Visualization is built in Chimera, a 3 C# and Python software built to assist in molecular graphics, and scientists had already discovered the symmetrical structure of the virus and had faked images of its form. So the visualization is built on top of the image that the microscope captures through 3D modeling. The visualization extends scientific knowledge by allowing a user to manipulate the virus to understand how its multiple layers might interact and penetrate cell walls. Layering, color, and interaction experience were key aspects of the aesthetics that designers brought into play when you read their description of their work. The next image presents 3D vector field, texture-based, volumetric flow visualizations of tornadoes. While the application is specific to storms, the algorithm, the data structure, and metaphor are of value to multiple disciplines that study flow, such as mechanics, physics, meteorology, medicine, such as blood flow, and geology. Advances in texture mapping, graphics capabilities make these images possible, and combines with depth sorting, illumination, haloing, and color attenuation to enhance perception and depth. The images are aesthetically compelling, drawn by the computer from the data points superimposed onto original photographic images and able to capture the dynamics of a storm. This image is a 3D visualization of a solar storm that occurred on Halloween 2003. NASA's visualization laboratory created it by combining a model of the Earth with daily average particle flux data from the SANPEC satellite by propagating the particle flux values along field lines of a simple magnetic dipole. By making flux and field lines visible, it is meant to illustrate the ways that energy particles from the solar storm transform the structure of Earth's radiation belts. Design decisions are apparent in the quote from the makers. Quote, "The color scale on the cross-section is violet for low flux and white for high flux. The translucent gray areas represent the field lines of the Earth's dipole field." So that's the image. Sorry, the other one was the, just to go back. So that's our second tornado, and that's our dipole image. So these examples bear close resemblance with what science has previously discovered or represented through photographic media. Yet each seeks to extend that knowledge in speculative ways through design decisions that move the image into the field of visual analysis. These images operate within a tradition of scientific description as tools for deductive reasoning. And one of the things I find so interesting, I was recently at Oxford at a conference that was entitled Data Visualization in the Age of Computation, and it was an S&T Studies conference. And folks in the S&T field talked about the ways that scientists built visualizations and the way that these operated within the lab and within that culture. And I was the only person who gave a paper that talked about the role of designers within the production process of data visualization. So there's this kind of incredible invisibility about that kind of agency. There are other great papers that gave examples of art visualizations that use science data, but in terms of the actual production process, I found that invisibility quite stark. And that's why, I mean, I know in a way you know what I'm saying, but I want to really emphasize this process of production. So the use of literal metaphors in data visualization may suggest a level of accuracy that is frankly impossible to achieve. After all, a visualization of internet packets or Earth radiation belts is many degrees of separation away from the conditions of production of what that packet is and its producers and the technological agents. Science itself contains varying views of reality, and its analysis is contradictory and chaotic, with different worlds, episteme and ontology, side by side. New trends in science certainly acknowledge phenomenology, complexity theory, and emergence, and there is a recognition that complex systems are difficult to predict and certainly to visualize. A further challenge to realism occurs when the source cannot be seen, only measured and then imagined. The strength, not the weakness, of data visualization is its ability to use algorithms to present emergent properties and different points of view. Just some more images. Beautiful. And David Wishart, who's a scientist I worked with when I was at the Banff Center, is a very interesting nanotech guy who uses very imaginary representations of blood processes for his own ability to navigate his scientific discovery. And he's working in the nano world. He's not working with photographic images. So you begin to get more and more comfort there with more abstract, expressive ways of using visualization. So case studies of visualization, working with the same data set, underscore how these sets are shaped by prior decisions, such as the instruments chosen to collect the data, the structure of the database, source and sampling methods, and software choices. Metaphors need not be literally tied to data structures to be meaningful, as the following interpretations of sets of data that analyze emotional expression in components of the Globe and Mail, Canada's national newspaper, represent, and secondly, then look at in terms of some of the service dialogues of Canada's online banking system. This work is an extension of my earlier research, a cross-disciplinary team co-led by computer scientists Anjan Un and Nick Sartoni from York University, myself and Fanny Chevalier at our institution as visualization researchers We are creating extraction algorithms and an analysis system and a set of visualizations with student researchers Simon Oliver, Gia Gali, and Jared Wilson. So the digital version of the Globe and Mail, like its print edition, includes a wide variety of sections, and I'm just going to kind of click through these to just give you an idea of how these students are looking at essentially affect extraction, the kind of stuff I was doing with Code Zebra, but using a more sophisticated, more precise algorithm, and just their amazing kind of imaginary of how they're working with that data. So we're looking at how the publication has added commentary in the form of opinion blogs by its core of writers, as well as ample opportunities for readers to vote and comment. Editorial and business leadership at the Globe see value in understanding the emotional content of their various sections. Writers and readers might use tools to choose articles, and editorial leadership is eager to better manage the means for reader commentary. Discovering sentiments, patterns, and relationships embedded in articles, as well as comments, is important for tracking the newspaper's role in shaping public opinion on contemporary issues and the ways that readers interact with these opinions. It can help media analysts to better understand the impact of sentiment in news events, and our research analyzes emotional expression in all of the critical features of the publication. So we compare sections, blogs, and articles, and look for underlying patterns in emotional expression using data extraction and visualization. We're using a unique context-based approach to identify the underlying emotional tone of text, combining machine learning, semantic analysis, computational linguistic techniques. The system is being implemented and evaluated on annotated data sets such as blogs and user comments. And this is really great because she's using color coding for motion, and then doing this sort of search of just news articles where that color is represented for police. So the point is that formal strategies and metaphors radically differ from each other in each example. Each offer different models of interactivity, whether passive viewing, building one's own visualizations, adding one's own data, or flowing data through the metaphor. And Gordon Kindelman proposes that the very power of data visualization is that objective and subjective views cohere, inspiring new insights. These works prove that very point. Given that data visualization can assist fundamental discovery or influence social policy and economics, it's no surprise that past applications of data visualization has been motivated primarily by teleological, that is, willful thinking and predictable outcomes with regard to both the goals of human activity and the ways that machines or tools can serve these. Visualizations are understood as utilities, translating data into meaningful communication that can represent reality and increase productivity. Edward Tufte proposes data visualizations as complex ideas communicated with clarity, precision, and efficiency, unquote. Perception about realism, common sense, and the ways discovery and insight occur have a direct impact on notions of beauty in data visualization. And so despite examples of aesthetically demanding, yet instrumental works such as those of Jer Thorpe, a belief in realism and objectivity leads some scientists to suggest that attractiveness is equal to subjectivity or illegibility. Ben Matthews, who's a designer, assigns aesthetics to functionality and the ease of the interface use. Rapid comprehension is then the goal of the design aesthetic, and simplicity is closely aligned to Occam's razor, or lex parsimoniae, the mathematical and scientific view that the simplest solution is the best and the most common sense one. The acceptance of beauty in scientific and information imagery differs between generations and types of science and designers. As visualizations of the truly imperceptible nanotechnology world proceeds, image making becomes generous. Andrew Van de Moore maintains the blog Info Aesthetics, which is a wonderful source.